All right, this is the potential energy worksheet. So, first thing, what is potential energy? In general, potential energy is stored energy. Another way of saying it is the energy of position. So the symbol for potential energy in your videos has probably been U. That's one way to do potential energy, or we do potential energy this way. I prefer to do U. The unit for potential energy, because its energy, is a joule. Now, we have a whole bunch of different kinds of potential energy. There's gravitational potential energy. This one is the most important. Gravitational potential energy, usually represented with a U sub G, and that's equal to mgh. That's the one that we're going to use in this class, is gravitational potential energy. That is not the only kind of potential energy there is. There's chemical potential energy. That's stored energy in the bonds of molecules. We have electric potential energy. Electric potential energy has to do with moving charges away and near each other. So, those are three big kinds. I'm sure there are more that you can think of. Can energy be converted between kinetic and potential energy? Yes, absolutely. In general, the right force, energy can be converted between lots of different forms of energy. But if we're talking about kinetic and potential energy, you bet it can be converted. Imagine this. A ball thrown up into the air, slows down and stops as it rises. In this case, when we throw the ball up into the air, it starts off with kinetic energy. So the way I like to think about this is energy. So if we start off with kinetic energy and very little potential energy, so we have a whole lot of kinetic energy, not a lot of potential energy. At the end, if we're at the bottom and we end up at the top, so this is the bottom. We end up at the top. We end up losing kinetic energy and gaining potential energy. So we have very little kinetic energy and a whole bunch of potential energy. And if we stop, it's all gone. And what happens here is that gravity is going to convert that kinetic energy into gravitational potential energy. Gravity is the force that changes it. We know we're losing kinetic energy because we are slowing down, and we know we're gaining potential energy because we're getting higher. How can gravity be used to store work? By lifting an object. So, lifting is positive work. But gravity does negative work. If we look at our object, the lifting force is up, the gravitational force is down, and we're going to go up. Because the lifting force and the height are in the same direction, we get positive work from the lifting force. Because the lifting force and weight are in opposite directions, we get negative work. So the net work is 0, but anytime gravity does negative work, so my work in this case is stored. Anytime we do work against a gravitational force, we're going to store that work as potential energy because we gave the object height. A classroom full of students is on the third floor of the school building. Would you define their potential energy to be 0? There are two ways that we can do this. Yes, if the problem never has objects going below the third floor. Then it would be really easy to say that the potential energy is 0 on the third floor. However, you could say no. If we drop an object to the ground, the lowest point should be the place where we put potential energy equal to 0. It doesn't matter where we put potential energy equal to 0. It just needs to be convenient. And convenient is usually to have it at the lowest point that an object's going to travel. So we have an airplane that has this mass and it's flying at this altitude. So the potential energy is mgh. So we're going to take 8,500 kilograms, multiply it by g, which is 10 meters per second squared, and multiply it by the height of 25,000 meters. As you can imagine, that's going to be a very, very large potential energy. When we do this, we end up with 2,125 million joules. The way to write that would be 2.125 times 10 to the 9th joules. That'd be our energy. That's a lot of energy. That's a lot of energy. All right, a mountain climber has a mass of 150 kilograms and it climbs from 3,500 to 4,500 meters. What's the change in the climber's potential energy? Well, if potential energy is mgh, the change in potential energy is going to be, well, just the things that change. So we have mg, those things stayed the same, but the height didn't. So our change in height here is 1,000 meters. So my potential energy is going to be the mass, 150 kilograms, times 10 meters per second squared, times my change in height of 1,000 meters. So my change in potential energy, it's not my total potential energy, it's just my change in potential energy, ends up being 1,500,000 joules. How much work did he do? Our rule for work from the work energy thing that we talked about, work is equal to our change in energy. Well, if the energy changed by 1,500,000 joules, then the work is equal to the change in potential energy, or 1,500,000 joules. That's the work that we did here. An airplane with this mass has an altitude of 15,000, and then it dives steeply to 11,000 meters. Same thing, we want change in potential energy, so that's mg times the change in height. I start off at 15,000 meters and I dive to 11,000 meters. So my change in height, since I'm losing altitude, is negative 4,000 meters. And so my change in potential energy is going to be 8,500 kilograms times 10 meters per second squared times negative 4,000 meters. So my change in potential energy comes out to be negative 340 million joules. One thing that's worth noting is that it's negative because height decreased. Going down is going to be a loss in potential energy. So this object of 30 kilograms has 4,200 joules of gravitational potential energy. What's the height of the object? Well, that potential energy is mgh, so 4,200 is equal to 30 kilograms times 10 times the height. So we'll just divide by 300. And that tells me my height is equal to 14 meters. You're going to need to know how to do things like that. You're going to need to know how to do things like number 8 too. An apple of mass 0.5 kilograms is 5 meters above the ground. It then falls to the ground. How much potential energy did it lose? Well, the change in potential energy is mg times the change in height. If we look at our problem, we're 5 meters above the ground, then we fall to the ground. That tells me the change in height is negative 5 meters. So my change in potential energy is 0.5 kilograms times 10 meters per second squared times negative 5 meters. My change in potential energy ends up being negative 25 joules. This energy went to another form of energy. Namely, kinetic energy. Gravity does work on the object. Work usually changes into kinetic energy when nothing else is working. Also, you know when you drop an object, it speeds up.